Everything you hear right now and the next few minutes is computer generated. This is not Joe Rogan speaking. This is an imagined conversation between Jordon Peterson and Joe Rogan, generated using ChatGPT, about a scientific paper that was released on the bioarxiv preprint server. Hey Jordan, I came across this really interesting paper on DNA origami the other day. Have you heard of it?
Yeah, I've definitely come across it before. DNA origami is a technique that allows scientists to create precise and programmable nanostructures using DNA, right?
Yeah, that's right. And these nanostructures have all sorts of potential uses in fields like biophysics, molecular biology, and even nanoelectronics because of their ability to organize other nanomaterials with such high accuracy. But one of the main challenges with DNA origami is that it can be fragile and unstable when it's removed from its optimal aqueous conditions.
Yeah, that's definitely a problem. But this paper presents a new method for creating more stable DNA origami structures by growing silica on top of them.
Yeah, that's really interesting. I can see how adding a protective layer of silica could make these nanostructures more stable and durable. And the fact that this method is so simple and highly controlled is really impressive.
Yeah, it's definitely a big step forward, and I can see how this could have all sorts of practical applications, especially in fields like nanophotonics, where stability is so important.
Absolutely. It's really exciting to see how scientists are continuing to push the boundaries of what's possible with DNA origami and finding new ways to make these nanostructures more stable and practical for real-world use.
Yeah, and it's also worth noting that DNA origami has the potential to overcome some of the difficulties that other bottom-up techniques face. It's a highly compatible method that allows for nearly atomically precise structures, and it's been particularly successful at organizing other nanoparticles with high positional accuracy.
Yeah, that's definitely one of the unique strengths of DNA origami. And the fact that it's a programmable polymer rather than just an information carrying molecule means that it has a lot of flexibility and potential for use in a variety of different fields.
Definitely. And with the nearly 6 decades of development in DNA chemistry, it's become possible to decorate these DNA nanostructures with all sorts of biological molecules and non-biological nanomaterials like quantum dots and carbon nanotubes.
Yeah, the possibilities with DNA origami really seem endless. It's definitely a field to keep an eye on as it continues to develop and evolve.
Absolutely. It's always exciting to see the breakthroughs that scientists are making in the field of nanotechnology, and DNA origami is definitely a promising area of research.
If you like what you saw and more importantly heard, do subscribe. We're going to be putting out more content like this where we use machine learning to create pretend conversation between interesting people about real science and technology that is shaping our future.